All right, so basically, I think it's page 78. Oh, what did we have before? I changed the numbers at the end. Okay, so today we're going to look at the initial notation for the del when there is the del operator involved. Okay, and basically we can say that the del operator is equal, depending on how you do it on the textbook, they put it this way, but generally I put it the other way, is a vector, so it has a magnitude that will be the partial derivative, and this would be the direction. Okay, so this is the definition of it. All right, so let's do the three, I think, A, B, C, D, and E examples you had, and let's see how far we can get. Okay, so the first one I think was the most complicated from the algebra, which is to show that the del operator of two vectors, or the dot product of two vectors, is equal to A dot B plus B dot A plus A cross del cross B plus B cross del cross A. Okay, so what I did in order to solve this problem is that I went to the right-hand side. You see, I took now a pen because for the subindexes. So if I need to magnify, let me know. Okay, you cannot see it, otherwise I switch to the other one. So the right-hand side is equal to what? Is A dot del B plus B dot del A plus A cross del cross B plus B cross del cross A. Okay, so as some of you did, what I've done is I broke this one into each one of the terms. So this will be 1, this will be 2, this will be 3, and this will be 4. Okay? So for 1, which is A dot del of B, you can just rewrite this one to be equal to what? So the indexes, they're not going to follow the normal order, but in order to make it work, that's what I have to do, okay? So I had to redo it like 3 times just to make it work for the indexes. It doesn't matter, you can still do it work for any index, but then at the end you have to say, assume that this k is equal to j or so on, no? But if I wanted to make it work from 0, I needed to do it this way. So this will be, let's say, A sub j, ej. Then this del operator is but the dot here will be ek partial of xk times here but bi e sub I. Okay? Then I use this notation. If you want, we can use a different notation. So over here, what happened is that we know that this term over here will be equal to the delta Kronecker of delta jk, no? So this implies what? This is only valid when k is going to be equal to j. All right? So from here, we get that this is equal to aj partial xj, bi e sub I. Okay, this is the notation I selected. Okay, but sometimes all the notation that I use, I've seen on my notes, will be a of j. This one will be partial of j, b sub I, e sub I. Okay, all the notation, no? Let me put over here all the notation. But I'm going to stick to this one. Okay, I might switch to that one later. We'll see. Okay, so this is our first term. So our first term, we have the first expression here. This one over here. So we go now to the second term, which is kind of similar. Would just be b dot of the a. So we follow exactly the same thing. This will be bj ej dot ek partial of xk, and then this will be now a I e of I. So exactly the same as before. This term over here will be equal to delta jk, which implies that k should be equal to j. So this should give you bj partial xj of ai ei, or if you want, bj partial j ai ei. Okay, but I'm just taking this one. Yeah, I'm out of space. Okay, the third term is A cross del cross B. Okay? So here I go slow. It's like, I started from 0. This is, I call it A of J, EJ. Again, don't ask me why I start with J. It's the way I like to do to make it work, okay? Cross. And then I call this one EL of delta XL. Okay? Cross B, and I call this one B sub M, E sub M, okay? So you see, I'm not taking any, and go step by step, no? So now the first cross product we need to do is this one, okay? So here will be equal to AJ, and now this one here, I call it L for EL, M, and K. Okay, so it will give us that. This partial of partial XL, B sub M, and the new one, the cross product of EL cross EM becomes EK. Okay, becomes EK over here. And here, don't forget the cross. I should have put it here, right? This one here. All right, so now we have this is equal to epsilon L and K. And now I need to do the one for this one, no? So it should be J because it's EJ. This should be K. And the new one, I call it I. If you look at it on previous results, I had the I, no? So I had to come up with this I from somewhere. So this will give you now, this will be epsilon L and K, epsilon JKI of AJ partial of XL BM, and EJ cross EK will give you the EI. Okay? Will be page 70 something, I don't know what. Okay, so now I need to do a summation through one of these indexes, so I need to put the one is in common is the k, no? You can either put it at the beginning or the end. So let's see if I put it at the beginning, we get epsilon k l m. Yeah, but let me just change the order here. Hold on 1 second. Let's say it will be epsilon, that way I know it's worked, Kij, epsilon KLM is the same thing, but it's just for the order. And then the rest stay unchanged, will be Aj, partial of XL, Bm, E of I. Okay, so now this will give you what? This will give you equal to the delta IL, okay? Okay, let's do it now. I was going to do it at the beginning, but since I started doing it now. So IL, and this will be Jm minus delta Im delta JL. Okay? And this will have the same thing, Aj partial of partial XL B sub M E of I. Do you want me to zoom in a little bit or is it fine?
It's good.
It's good? Okay. Okay, so now we need to do two things. So the first case would be what? So case one would be for L equal I. M equal J, no? First case, correct? So this should give you what? So it give you A of J partial X of Xi, the L becomes I, and B M becomes J EI. Okay? Now for the second case, so this is 1, this is 2. For the second case, what do you have? M equal I and L equal J. So we have minus A J partial X of J L equal J, okay, and M equal I of B of I. Okay, so basically from here what we get is that, let's see, we get that, what is that page? That A cross del cross B is equal to this stuff on top. So AJ partial XI B sub J EI minus AJ partial XJ B sub I. I forgot to put here the EI. EI. Okay, and for the last term, we do something similar. So the last term is B cross del cross A. Okay, so similarly on that one, I'll rewrite it as B sub J E of J cross what did I use before on the previous one? So EL partial XL cross A of M E of M. Okay, so basically everything remains the same. We'll switch the orders of the A's and B's. So it would be equal to Bj E of J cross. Here we're going to have the epsilon L and K of partial XL A sub M, and then EL cross EM will give you E sub K. Okay? Now, by doing the other cross product, we're going to get epsilon L and K, epsilon J for this one, K, and the new index will be I of B sub J partial XL A sub N EK. So just for the same as on top over here, we write this as being epsilon Kij. This one?
No.
Oh yeah, it's EI, correct. Because the EJ cross EK becomes EI. EI, so epsilon Kij, I'm just putting here. So we have the same notation. Epsilon K LM. Okay, doesn't change the sign because both still go clockwise, no? All right. Of B sub J partial of XL A sub N E of I. So we can copy almost what's on top. So it would be delta IL delta JM minus delta IM delta JL of BJ partial of XL AM DI. So as before, can use exactly the same thing as before. This is 1, this is 2, L equal I, M equal J, first case, M equal I, L equal J, case 2. So the first one will have B sub J, L becomes I, partial XI, and M becomes J, so A of J, E of I, minus Bj, partial of X, this time L becomes J, and M becomes I. So that means that B cross del cross A will be equal to Bj partial xi aj ei minus bj partial j ai ti. All right, so combining all the expressions, basically what do we have? We have our initial equation, which is, so this one we have a dot del b plus b dot del a plus a cross del cross b plus b cross del cross a. Okay? We found 1, 2, 3, 4, no? Our four expressions. So let me zoom out a little bit because now it's being too much. All right, so if I go back to the pages, the first one is this one over here. So we're gonna have a j partial xj b of I. I mean, okay, I'm gonna keep the ei, but you see all the expressions have the same ei, no? So we could almost remove it to save some space. So can I just remove it? They all have the same ei, no? Yeah. Okay, see if I can write everything on the same line. Plus the second expression is this one over here, so the bj partial xj of a sub I. All right. The third term is this one over here, so we're gonna have plus aj partial xi b sub j minus a sub j partial x of j bi, and the last one is plus b sub j partial x sub I a of j minus b of j partial xj a of I. So if you see this term over here, we cancel with this one over here. It's identical, no? And then we also have this second term that we cancel with this one over here.
I think it's the other.
Oh, I took the negative one. So yeah, this one with this one. Sorry. So this one is stays. Okay. All right. So basically, this is going to leave us with what? We're left with aj partial x of I bj plus bj partial xy AJ. Okay? And this term over here at the end really is equal to what? It's equal to the del operator, no? Of A. These two have the same index. They have the same index. That means that it's like doing the dot product, no? Yeah, of A and B. And this is basically what we needed to prove. Okay? So I went through very quick through your exam. I think what most of you did is to take every single term on each side, then you did this one and you compare term by term, no? Which is perfectly fine. But basically here what I did, just went from here and end up to this one, no? Okay? All right, so this one was a bit long to do, but it wasn't that complicated. I think is the next one is the one I wasn't able to figure out why. I mean, to switch the negative sign without really knowing how to do it without knowing the result. Okay, so I spent like half an hour. I wasn't able to figure it out. So let me just put these pages in order. So we have this one, and this one. Let me go to different. So problem B was to show that del dot of A cross B equal to del cross A dot B minus del cross B dot A. Okay, so over here what I did is that I started with the left-hand side, which is del dot of A cross B so this one I rewrite as being equal. Let's see what is notation I use on this one. E of I partial xi. Actually, I'm using the different one than the one I have here. I use the other one. And now for this one, we're going to use so dot of looks like I use for A. I use so AJ EJ cross BK is of K. Okay, so we first do the operation over here inside the parentheses. So this will be EI partial xi of epsilon jk and looks like I use I for that one, so it will be AJ BK and EI, which is convenient because I do EI and EI, which is the appropriate one, no? Okay, so if you want here, you're gonna get what? This is gonna be equal to partial xi, if I do in detail, of epsilon, let me put the parentheses, I think it would be more clear, I should put ijk, okay, it doesn't matter, we do the next step, aj bk And the good thing about here is that what we have e sub I dot e sub I, that would just be 1, no? So it would be equal to delta I, which would just be 1 over here. Otherwise, we're going to have to change the indexes. I mean, change the, say this one would be equal to the other one. All right, so this is the middle step, useless, but I'm going to write it down. So it should be equal to, or maybe I can do, I'll do it, the middle steps of partial xi of epsilon I jk aj dk. So now here, we need to take these two vectors over here, no? Or two functions. So if you do the function of the derivative of two functions, what are you going to get? ijk. If you do the derivative of the function uv, you get u prime v plus uv prime. Yeah? So here we're going to get then epsilon ijk of delta aj delta x of I times bk plus epsilon ijk aj partial b of k x of I. So over here, I have to admit it, I don't know, I wasn't able to figure out. But in order to change this one, what is the only thing I can do? Change the order of this, no? So then we have negative, negative becomes positive. Another big fan of this stuff is what I call cooking engineering, no? Or cooking mathematics. You know the answer, you make it work so you get the answer. But I tried to work it out, trying to expand every one of the coefficients. I spent like half an hour yesterday, I wasn't able to get it. Okay, hold on 1 second, if you have a comment. All right, so here what I was saying is that I see this is negative, so this is not good mathematics. So I'm basically doing what I say, cooking mathematics. So I end up here putting epsilon I jk partial of aj partial x of I bk minus epsilon jik, I change the order, so it's become negative of a sub j partial b of k x of I. Okay, but I'm going to say right away, okay, and this is equivalent to basically b maybe the notation is not perfect what I did here. This is equivalent to b dot, okay, I should have put the dot on the other one of del cross A minus, oh, I changed the order here, okay, okay. I should have minus the A dot cross B, okay? Which is what we have here, but I'm gonna put over here not a very good proof. Okay, so let's do now the way you just told me. That is more clear, no? From here to here is a bit of cooking, all right, because you need to make up to know the sign. Okay, so we're gonna say here, or starting from the right hand side terms, okay, which are what? Del cross A dot B minus del cross B dot A, okay? 1 and 2. So for term 1, so you use over here, you wrote this as, correct me, that's not what you have, E sub I, partial x of I, cross A of J,
Well, dot. It's dot. Oh, no, you're right, sorry.
okay, A of J, and now here you use of dot of Bj, of Bk, E of K, okay? So first you need to do the cross product, no? So you first do the cross product, you're gonna have epsilon of I, J, and I guess you could put any index, but K would be the good one, no? To make it match. I, J, K, and this will give you now of partial x of I, A, J, and then you have here EI dot EJ will give EK, no? So we can say here just all right, EK, let's just dot BK EK, no? Okay, maybe I just put in too much detail here, so this will be equal to epsilon IJK partial x sub I, A sub J, B sub K, and here you have E of K dot E of K, which basically is what? And you leave it this way.
Yes.
All right, so now we go to term 2.
Yeah.
All right, and we do exactly the same thing. So term 2. Now we'll have the same thing, so it will be E of I partial x of I cross B of J.
K.
I'm doing the same thing as this one.
So no, keep the K. So if it's B, keep K. Because B was K at the top.
Oh, I need to keep K over here? Okay, I get it now. So this one is K, so it becomes then EK. All right. So this is I, K, and now keep then.
J.
So this will be dot now, AJ, no?
Yeah.
Okay, I see what you've done. E of J. I did not do that. I did not think about doing that. Now I see what you've done. So I have this. So basically, if we first do the cross product, we're going to get epsilon of I, K, J, which is the change of the order. And then you have of partial x of I, B of K, A of J, and again here you will have the E of J dot B of J, no? Which is 1. Okay, yes, so you're absolutely right. So combining the above terms, we have that del cross A dot B minus del cross B dot A will be equal to what? So the first term will be just epsilon ijk partial of x a sub I a sub j bk.
Just keep it as it is right now.
Yeah, I don't have to change anything.
Yeah.
So ikj, yeah, I don't have to change anything. It's x sub I b sub k a of j. And the only thing we need to say is that this one is
1.
positive 1 and this one is negative 1. And maybe we can just put here to make it a bit more specific. Let's see, we have I, j, k. That will be positive on the counterclockwise, negative on the other one, no?
Yeah.
And this, just like you say, so yeah, do nothing about keeping the same indexes on the variables going one to the other. So this is exactly here, del of cross A dot B minus del cross B dot A as requested. Excellent. So I think that's going to improve the notes. Okay. Now that you give me the other one.
You can do it from the first way also,
Yeah.
From the first part over here.
the way you did it the first time.
If you keep the indices, you'll see it.
So let's see.
Check.
All right. So the last one probably we're going to have time to do is show that. Maybe we have time to do two more. Is that del cross of the gradient of a scalar field equal to 0. Okay, so here what they mention is that f is a scalar field. So if you had ME501, this is one of the expressions you need to prove. Okay, in ME501. So anyway, what is a scalar field? So it's not, I know you concentrate here about the term scalar, but think more about the field, okay? If you have like in ME501, you study what? Like you study like a magnetic field. You can choose what is the field created by the flow, no? Okay? Or, so basically what it means is that you can have a surface that has obviously multiple points throughout the surface. But if you pick one point, that point is just going to be equal to always a scalar value independently of the coordinate system. Does that kind of make sense? Really what it means is that if you have a plane and you calculate one point, independently of the coordinate system you're going to use, you're always going to get the same quantity. Okay? So it's a scalar, but it's not like a scalar like in, you know, like you do like 2 times 3, no? It's still a point on a plane. Anyway. So a scalar field, let me just put the definition. So a scalar field the definition is a function of a space whose value at each point is a scalar quantity. Okay, so what that implies, so implying that it is independent of the reference frame instead of current system. Okay, so what I did on this one, I start from this side over here. This is no secret, it's only one side. So and this will be equal to so this would be now the del. So again, the same operator, let's use her trick, needs to be same index, no? That way we don't have to do it afterwards. And then we have F over here. Is that correct here? Maybe use a different one. It might work better. Okay. So now we do this cross product. We're gonna get epsilon, let's say of I jk of partial xi partial xj of f. Or here the trick is to realize that this is equal to I jk second derivative of f of a sub I x sub j. What is really this derivative here? So anyone recognize this one? Right, this is 0, but this is what they call in ME548, that was the Laplacian, no? Okay, and if the, remember, the field is continuous and irrotational, the Laplacian is always equal to 0. What is called is the space which is monoclinic, okay? All right, so, but from a mathematical point of view, we can rewrite this as being equal to what we can do. This is equal, this is a strange derivation, but this is equal to 1/2. Yeah.
Oh.
So anyway, this is when the field is equal to 0. So let's break this one in two parts, okay? So it should be equal to 1/2 of epsilon I jk partial of xi partial f partial xj plus epsilon I jk partial of f partial f I partial x of j. Okay, because I do, this is half and half, no? 1. So this gives you at the end what? This is equal to 1/2 of the same thing, really, of epsilon I jk of second derivative of f xi xj plus now if I change here the order again, it's like so what can I make here? Jik or ikj. I is ikj of partial of f partial x sub I x sub j So basically you end up with 1/2 of this will be positive.
Might have switched the values.
Here the same, I mean, we need to prove this is equal to 0. So basically it's the same as before. Here this should be, if you switch the indexes, you are not switching the value for this one, since this is a scalar field. But again, I agree with you. This is a little bit like, why do I switch it? Because I know what I need to prove. Yes.
I actually did a little bit different. So you see the second line, that's one actually.
This one.
Yeah. So from that one, I just flipped the indexes. So it was like delta xj, delta xi, and then.
So from this one, you went to this one.
Yeah, I mean directly, and they proved that that one equals minus of the other one. And if it's
Yes,
like
right.
if it's equal to minus.
Basically, this what it means is that the function is continuous.
Yeah.
That it doesn't matter if you first. What it means this is important when you do stresses later on. You're going to see this have the expression. What does that mean? Is that if you need, let's say you need to go from here to the corner over there, it doesn't matter if you first go to that corner and then to the other one, or you first go to that direction and then to the other one. That's basically what it's meaning, no? That is path independent. You have a question?
The way I do it is if we keep the two del operators the same consistency, your epsilon will be epsilon I k. Which
Okay.
is 0.
Okay, yeah, I see. Yeah, basically what it is. But what I want to say is that mathematically, what does it mean? This is a proof, but it wasn't more important to know what it means. No, is that it means basically that it's path independent. It's continuous and path independent, the function. Okay? Because this is, what does that mean? What was the definition of ME501? Is that if a field is continuous, okay, what does it mean? Del of the field is equal to 0, no? Okay? And if the cross product of a field is equal to 0, it means that it's irrotational. And the implication of a field to be irrotational, it means that it's path independent. So that's basically what does that mean. Okay? Just like if you're doing fluids, you do the del, or if you want to get in, of the velocity field is equal to 0. Okay? That means basically that is continuous. Now, if you do the del cross of the velocity field and equal to 0, it means that it's irrotational, but irrotational implies that it's path independent. Here you do those two things in one step. Because really what happened is that this is 0, no? This time over here is really 0. So you can do whatever you want, cross or dot product, with 0 is still going to be 0. Okay? All right, so how much time we have? 7 more minutes. Okay, and this one is E. We need to show that. See if we can make it. Show that if V equal omega cross R, even though, okay. Show that okay, so here we need to be careful because again, omega here is like a scalar. We'll see. Okay, we'll see what happens. All right, so let's start by the first one. Del cross V will be equal to EI partial X sub I cross V, which is, okay, maybe I want to do it in 2 steps, which is omega cross R. Okay, so this is equal to E sub I. I should have switched to the pencil. Okay, of J, sorry, use J for this one. That's gonna get messy. J cross R of sub K, E of sub K. I'm gonna switch to the pencil. So this will give you E of I partial X sub I cross epsilon J K L, let's say, of omega sub J R sub K E of L. Okay, so it will give you now epsilon I L, let's see what index I use here, M, epsilon J K L of partial X sub I omega sub J R sub K E of M. Okay, so here just using by definition, so let me write this I L M epsilon J K L of omega J, where R here is, what is R? You know this stuff, R is the position vector. So if I take the derivative of this one with respect to this one, I take partial of R sub K, partial X sub I. Okay, this is something that I got from the book, and by definition, partial of R sub K, partial X sub I mean, it's equal to the delta of Ki, because this needs to be equal, no? Okay? So I'm gonna write this as epsilon ILM, epsilon JKL, omega sub J, delta Ki. Okay, one thing I forgot here to say. I was going fast, I forgot. Now, if you take the partial derivative of this one, what do you get? You get partial derivative of this times this one plus the partial derivative of this one, no? But what is the problem with omega sub j? Is that we say initially was a scalar, no? Yeah, so when you take the partial derivative is 0. Do you see what I'm saying here? I missed this one on this step. Okay, so maybe you want me to do it? I think it's better if I... So let's say missing step, and then we keep going. We have epsilon I L M, epsilon J K L of partial omega sub j x sub I times r sub k plus omega sub j partial of r sub k, which is the one over here, alpha x sub I. So we say this is equal to 0 because omega was assumed to be a scalar, no? And that's how we ended up with this expression over here, no? And this expression here is what we say is delta ki. So this missing step should go right here. Okay, I think it's important, no? Otherwise it misses everything. Yes?
How come omega is now a scalar if it started off being a vector?
Yeah, what happened is that when I copy the stuff, I put this one to be, because it will make no sense. The problem is notation. It makes no sense to put a scalar on the cross product because the product is always, the cross product is always between vectors. You cannot do the scalar, okay? So what happened is that what they ask you to prove actually is that the scalar of the del with a vector field is equal to 2 times a scalar quantity. So it's about, I didn't know what to put over here. Now, if I put it here as a scalar, it's wrong. And this one is, it will be wrong. So I put it here, over here, no?
Yeah, because if you do the cross product between two vectors,
You get a vector, you get 2.
So how do we get it to be a scalar?
On the problem statement, they had a scalar here. That's why on mine here. Otherwise, this one is never going to be 0.
Yeah.
So, and that's the problem. So,
Hence I couldn't prove it.
yeah. So anyway, let's finish, and then I will go back to this. So now, if we do this, what do we get? We're going to get, I'm going too fast again. All right, so it will be epsilon L Mi epsilon Ljk of omega sub j delta r sub k delta x sub I. And this will give you this equal to delta mj delta ik minus delta mk delta ij. And this will be, okay, so I didn't change notation, so it will be omega sub j of delta k sub I. This is again delta k sub I. So for j equal m, for k equal I on the first case, what do we get? We're gonna get omega m of delta I, and then on the second case, when we're gonna get I equal to m and j equal to k, 2, we're gonna get minus omega k, and we have k I equal to m, delta km. So basically, this is going to give you a delta. This one is equal to what? This is equal to delta 1, delta 2, delta 3, 3. So it should give you 3 omega sub m. And this one will only be valid when k equal m. Yeah? So minus omega m, we should give you the 2 omega m, or 2 times omega. Okay, now let me answer. I was just thinking about the question you asked me, but let me just end this stuff here, stop the recording.